And 30 seconds of focus. Hello. What's up? Talk to me. Break time. So thinking about the idea of respect and where it fits in our mission and vision. The vision of our school is that we want a place where everyone can thrive. Thrive means like doing the absolute best that we can. Okay, it doesn't like if you look at two plants and one is like wilted and the other one is all bloom, the one that's blooming is thriving. There has to be a change to the one that's sick, maybe more sunlight, more water, better food. Okay, so we want a place where everyone's thriving, okay, doing the best they can. And one of the things that you can do for people to help them feel like they can thrive is to respect them. Right, even that person is your friend or close acquaintance, you can still show those people respect. Okay, and you do that by looking at people, talking to them, not complaining when they're your partner, not wishing other people were your partner. These are all very small things that we can do to make sure everyone feels respected. Quick. Many things from the other day. Name two kinds of evidence that continents were once connected. Pablo Chabon. Fossils was one, and what was the other one? Remember? Yeah, they fit together, they're kind of shape. Okay, the shape, right? Number two, what is a fossil?
Wait, so what is the first one?
Fossils are the same on different continents. Do what? Sure. And then they shape, they look similar. Tomas, what is a fossil? Yeah, it used to be alive, now it's a rock, right? Cool. Used to be alive, now it's a rock. Three, Julia, why can we use matching fossils on different continents as evidence of past plate motion?
That makes no sense that they have crossed all the...
Yeah, they wouldn't swim across the ocean. Okay, it makes more sense they were connected. Juana, when we think about shape and fossils, what kind of claim can we make about past plate movement? Thinking of the evidence that we have about shape and fossils, what kind of claim can we make about past continent positions?
That the continents were different.
Yeah, they used to be juntos. And why is it better to have two pieces of evidence instead of one? Okay. The more evidence we have, the stronger our claims are. Okay, the more evidence, the stronger our claims are. No, you'll get everything on Thursday. Hey, what do red blood cells do at a wound site, Sophia? What do red blood cells do at a wound site?
I don't know.
You don't remember? Somebody help you, Sophia, out? Nobody remember?
Yes.
Tommy?
I think they go together to form like a scab.
Yeah, the clot, right? So they clot, they stop bleeding. What do they do?
They make a blood so it stops.
Stops bleeding.
I
Awesome.
have a question. Which one was 3 and 5?
We'll get there. Today we have to go fast because I don't see you tomorrow because of the entry point. Okay, so we have to do 2 lessons in one, so we'll go fast. We're going to be adding to our evidence about plate movement, and we're going to be able to explain how a marine fossil can end up on the top of a mountain. Both those things. Hold on a second. I think I have a gift for you. Here, I think you left it here. No, because then that would disrupt your quarter 3 grade, so I just want to wait a little bit. Okay, so vocabulary today, if you have this on your vocab page, you don't have to copy it again. We have something called a mid-ocean ridge We have seafloor, we have crust, we have uplift, and we have erosion.
We already.
Some uplift and erosion you probably should have already.
Yeah, we already.
And then we have what is a mid-ocean ridge, what happens to the age of seafloor rocks as you move away from the mid-ocean ridge. Older seafloor is farther from a ridge. What does that suggest about how new seafloor forms? What are two processes that can change a mountain's height over a long time? One that builds up and one that wears down, and explain how marine fossils can end up high in a mountain range. And you should know all of that by the end of today. For what? For the definitions? Put what you think is important. You never copy. Always say, what's the best information to put in? That's what I'm saying. If you already have it, don't do it again. Probably do have uplift, you probably do have erosion. You're going to miss a ton of information, but I am recording, so you need to watch the video. If you don't have it, Alright, this is a table. Talk to your partner. What do you see? What do you notice? What's going on? Just have a brief discussion. What's there?
What I noticed is that every single one of them give the distance or years something like the distance west reach 0, 100, 200 and that. H west 5, 4, 8 and that. The distance or years. The distance or years. Because H west millions of years. H east millions of years.
Alright, same table. Write down something, a pattern that you think you see. What do you think it means? Just in your notebook. Write down something you think you see and what it might mean. It's a pattern that you see. Another 20 seconds. All right, so on the first of the title it says seafloor age, both sides of ridge. So we have something called a ridge. Seafloor is like you go in the ocean, you go to the bottom, there's ground down there. That's what we call the seafloor. Okay. Something to the west of the ridge, distance 0 to 500 kilometers, age in millions of years, from 0 to 500. And again, east would be the other direction, and similar, right about the same. Okay, so as you get farther from this ridge, does the floor get younger or older? Vicente. The farther away we get from the ridge, so the numbers that go down, is the seafloor getting younger or older? It's older. Okay, so the closer we are to the ridge, the younger it is. What does that look like in a map? So this is those same numbers, but like a heat map. This is the mid-Atlantic ridge that we're looking at. Okay, to the right is east, to the left is west. So you can see like the color represents millions of years. So we're able to test things. I think it's like carbon dating, so we can tell how old something is.
But there is
Okay.
nothing in like
The purple, like here, like along the coast. Here it's a little older. Here it's really old. Okay. But again, the main pattern is the farther we get from this thing called a ridge, the older the ground is. And so what we think is happening, because we have new crust here, so crust is kind of a piece of the mantle, it's the ground that we walk on. We have newer crust next to something called a ridge, older crust away. Something is happening in the ridge that's producing new land. Okay, so if something's producing new land and it's making the old land spread. Okay, that's that pushing effect. What's that one? So a ridge, great question, looks a little bit like this. Almost like I read your mind. Okay, so it's this thing in the middle, it almost looks like a mountain, but it's being pushed apart. It's being pushed apart by what we think, and it doesn't need to know this part, but something called magma. So underneath our earth is liquid rock, and it's there all the time. That's probably what's causing all the movement that we see. Huh? You don't even know. You don't even know. As you move on in your geologist life, it would become important, but right now it would be too much information. Comes up, and then turns into new crust. And then more comes up, pushing, right, the plates apart. So this is where we get that spreading idea. So one thing, if we want to talk about a surface feature of a spreading boundary, is a ridge, okay, or a rift if it's above ground. So I'm going to pause, and I need to make a model. So again, lots of stuff today. But if I want to make a model of this, I have two plates. They're moving away from each other. So we call that spreading. And now we know that older floor and younger floor, younger, older. So something is coming up here and kind of creating new seafloor. Okay, and that creation of the new seafloor is pushing all the plates apart. Again, this is a very slow process. This is happening over. I mean, if you even go back to our table, right, and the mat, like 500,000 years, like that's a lot. That's 500,000 years. Right, that's still a lot. Okay, so this is just a very slowly incremental thing. Questions real quick about our spread seafloor. So we're going to move on in 3. We're going to move on in 2.
What?
Sophia, what's up?
Like in the separating things, like does it like is it together and then it separates, or is it like?
It's probably for the last 20 million years, it's been slowly, it was together more, and now it's been separating. So again, this goes back to this idea of South America and Africa used to be connected. Okay, if we go back to the map, again, that's what we think. That's our best claim, because of the evidence that we have, is that South America and Africa were connected, and over the last 280 million years, it's been being pushed apart by this ridge. Okay, so like this ridge first was just right here. And again, it kind of goes all along with that. So everything looks like it used to be together.
And the magma separated.
Yeah. All right. Good question. Okay, another piece of evidence that we have is something called rock strata. Okay, what is it called? 1, 2, 3. Rock strata. So you can see the different layers. Again, this is over millions of years. Things live and die, and things happen. There's floods, there's rain, there's ice ages, all sorts of things. And so each layer is a different geological period. So this is, again, over hundreds of millions of years. So if you look at anything that's been cut away, I think driving through some places in Colombia, you can see rock like this because the mountain has been kind of cut apart. And so this looks, okay, to be millions of years and millions of years and millions of years. And one thing that we found is that South America and Africa have similar rock strata. Like they were together, and then they broke apart. Okay, so that's yet another piece of evidence that we have where we can feel pretty comfortable saying that these have been moving. Do we know that for a fact? No. Okay, but that's our best guess based on the data. Okay. Now we have to move into this idea of how can a marine animal get on the top of a mountain. Okay, so the very first thing I'm going to show you is an animation.
We're going to have a break today.
After this, how can a marine fossil get on top? Did I say animal instead of fossil? That would be weird. Okay, so this is India. This is Asia. This is like 500 million years ago. In between India and Asia, before India collided with Asia, what do we have? We have an ocean. Inside that ocean, we have creatures.
They are not spreading.
Okay. These two, this India collides with Asia because we have mountains. So this is a separate thing. All right, so we have ocean there. There's things living in it. All of those things will die. Some of those things become fossils. Okay, so there's fossils on the sea floor. As India, oh, that's not what I wanted to do. As India collides with Asia, that seafloor now has been smushed in between, right? And is now becoming part of the mountain. So wherever that fossil was, it's now part of a mountain as we have that uplift. So the rock's going up, over millions of years.
Oh, what is that?
And so this goes up and up and up and up. And then we have the Himalayas, we have Mount Everest here. Here's India.
And how we know that they are separated?
How do we know there was separation? Mainly because we find marine fossils on Himalaya. Doesn't make any sense.
And how did they?
Because there's no way that you have a mountain and then the ocean just like rises above it. Right? That doesn't make sense. Okay, it's kind of like the animal swimming across the ocean. The same sort of idea. Okay, so we have the ocean floor. That ocean floor gets collided upon by India and Asia, and then it becomes part of the mountain. Okay, this part down here, this is different plates that get sucked down into the lithosphere and the magma and all that good stuff. So again, this is how the Himalayas and how Mount Everest was created. We have India colliding in to Asia. Part of this land is ocean material, and part of that ocean material is fossils.
Is there like still a river?
A river?
Like what is that little line?
That's just showing you the ocean floor that's being smushed in and made part of the. It probably doesn't look like that. It's just trying to make it. Again, like when we do these animations and models, it's not real life. Okay. So now I want to point out two different mountain chains. We have the Himalayas in Asia, and then we have the Appalachians in North America. Okay. Oops. That's not working still. There we go. No, nothing. Oh, that's interesting. Sometimes it just stops working. No one knows why. We have Mount Everest, which is the tallest mountain in the Himalayas, at almost 9,000 meters. We have Mount Mitchell, which is the tallest mountain in the Appalachians, about 2,000 meters.
But Mr. Light, I have a question. Like in the thing that India and I don't know what crossed through like right now, how did they get close to it?
There was some mechanism that was drawing them together, probably magma underneath, like pulling everything
What
together.
is like the magma? Like spreads, doesn't plates like
Some spread it, and then others will kind of drag it. It all depends on how it's flowing. This is where we're getting too complicated now.
doesn't know the crust. They don't understand that.
All you need to know about the crust is that the ridge is making new crust. That's it. It's just land. It's a different word for land and material. Okay, so Mount Everest we think is between 50 and 60 million years old. So talk to your partner. How old is Mount Mitchell? What do you think? How old? 50 to 60 million years old. I am 5, 4, 3, 2, 1, 0. Let's get some guesses. Yeah,
15 to 20 million.
15 to 20 million. Yeah.
10 million.
10 million. 18.
20 to 25.
20, 25. 15. 30. Anybody else going once? Going twice? 23. 5. 15. 1.1 billion.
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 So more
Not
than
million. Billion.
It's 10 times more would be 500 million. So it's double that, so 20 times older.
It's older.
Is way older. So what happened? Okay, they think that Mount Mitchell was bigger than Mount Everest. They think. Okay. So what happened? So we have a boundary, we have collision, we have uplift, and then it makes a mountain. At some point, there's different reasons why, we don't have to get into it, but boundaries stop colliding. All right, it just stops. Okay. So when the uplift stops, they stop moving, like they stop colliding. So when that stops, and uplift stops, because uplift makes the mountain. Okay? The mountain starts to get smaller. Why does the mountain get smaller? Did you have a question?
Yes, I have a question.
Yeah.
You know exactly what we're doing.
I mean, they can test stuff, and they do this thing called carbon dating. I don't really necessarily know how it works, and I've heard it's not 100% accurate. But I think based on what they found there, they can safely assume that it's a billion years old. We have a process called erosion. Okay, so erosion is water and wind, all this stuff taking away material, taking away rock. So this is someplace in like Asia. So they showed 15 years of erosion of water dropping on a rock. They showed 20 and then 50. So you can see the differences. Biscuits. So here's the dent. There's like a valley here. And then 50 years, you can see it, and it's much deeper. So that's only 50 years because someone set that up. They set it up 50 years ago, and then 25 years later, someone turned on another piece of water, and then 10 years later, someone turned on another. I don't know. They're very smart and very patient. Okay, and they wanted to show erosion. Okay, so erosion is this systematic removal of rock. We can have erosion come in a bunch of different ways. All right, some of it by wind. Okay, wind can cause things to change. Water causes things to change. If you have a little creek or a little river where you live, or where your finca is, if you go every once in a while and take a photo and compare the past, you will see change. Okay, because rivers and water is always moving stuff around. What's up, Lorenzo?
Like the waters of our rivers like start to fall.
Yeah, it can change everything. We have this one little creek at my house, and like the amount of like dirt that it comes in, the amount of change is pretty incredible. This is the Grand Canyon. The Grand Canyon was made by a river, right? Millions and millions and millions of years of a river moving cuts through the land. Okay, so erosion is a very powerful force. So if we have uplift and the boundaries stop, then uplift stops, but we still have erosion. What happens to the mountain? It gets smaller. Okay, so that's why Mount Mitchell is much smaller than Mount Everest, but it's much, much older because it's just not growing anymore. It's just getting all of this erosion, okay, removing its height. Yes, ma'am?
So like in, I don't know, like in 100 years, maybe the Everest will be lower.
At some point, probably not in the next 100 years, but at some point Mount Everest will stop growing. And it's still growing now, we think. From what the like the data
But
points and stuff?
it will stop growing or it will short.
At some point it will stop, because right now it's growing and there's erosion. Right? There's still erosion happening on mountains that are growing.
But it
It's just
could-
not making it smaller.
It could slow down like
The growth?
yeah,
I mean,
the-
if your erosion increases, but your growth stays the same, you're not going to grow as much.
like if you show them like the Everest, like there's like 3 centimeters a year,
Yeah.
and it could slow to 2 centimeters every year.
If there's more erosion based on like climate change, or maybe there's more rain or something like that happen, you can have more erosion.
And it could get
Smaller? I mean, that would have to be a lot more erosion than they're having to stop the growth, because right now it is growing and the erosion is not making it smaller. So what would that look like? So we have, how did I want to do this? We have then, so this was hundreds of millions of years ago. You have India, you have Asia, and in between them, at this point, you have ocean, right? You have an ocean. And then on that ocean floor, you have a fossil. Then later, oops, they're moving towards each other. They're going to create a boundary. At this point, there's probably a boundary here and here. Okay, something's going on. But in the middle, we have that fossil. Later, we have India is now attached or colliding with Asia. And that collision causes uplift. So now that fossil that was on the seafloor has now become part of the mountain. And it's kind of underground, right? But now what's happening is there is erosion all the time. Right? We still have uplift happening because they are still colliding. Right? The mountain is still growing, but we also do have erosion. And what erosion does is it removes rock. And so if you have a fossil and on top of the fossil is rock, what happens when all that rock disappears? You have a fossil. Okay, so we have erosion. Erosion removes rocks, and now that fossil, 500 million years later, is now being seen by people. Okay. All right. At this point, write down 3 things of the many that we talked about.
the surface.
What's that? Sophia?
How does the surface like start and then
What's that?
How-
Collide and uplift. That's uplift. They collide and then they cause uplift, which then
What's
creates
the
mountain.
name of the
Erosion?
no,
The ridge. The
Yeah.
ridge? So again, yeah, that was a bunch of stuff. So we have a ridge, at the ridge, we have ridge, erosion, uplift. The ridge is where new seafloor is being made, and the spreading is happening. Then we have continents colliding, causing uplift, and then we have erosion that takes rocks away. So all that stuff is covered. Uplift. At that point, we've asked a bunch of questions, so we can go to break. bottom drawer.
Are we going to do that?
To do what? Oh no, that was it. I did both lessons. Now we're just gonna do some work.
Thank you. Thank you.
Alright, so the way that we're thinking now, what makes the most sense? Okay. Do we say that there was a mountain and the ocean just rose all the way to the top of the mountain, an animal died on the mountain, like died, and then the mountain just collected it and created a fossil, and then the water went away, and that's why a marine fossil is there, or do we have a different explanation? Isabel, what do you think? Is our explanation for fossils on a mountain that the ocean just surrounded the mountain? So right now we have an explanation for why there's fossils on a mountain, marine fossils. Is our explanation that the ocean kind of surrounded the mountain? So the mountain was there and the ocean showed up, was there for a while and then disappeared? Is that our claim? No, what's our claim? Alright, so we have the plates and there was an ocean there. Okay, cool. So Tomas, if we think about these very important words, can you build our claim for us here? With these three words here. Why do we have marine fossils on a mountain?
Because we have marine fossils
On the top of a mountain, yeah.
because the mountain, in the beginning was inside the
Okay.
inside the ocean. He started to go up, and animals died in there when he got down.
Okay.
And when he got to that top, and we discovered the animals.
Okay, and the reason that we discover the animals is because of erosion. If you've ever been, where is it? Do I not have it? Oh man. If you've ever been to Villa de Leyva, yeah? Villa de Leyva? Alright. You have all these marine fossils. Why?
The other crocodile.
Right.
No,
So you have this huge marine animal.
Is that a crocodile?
What is that?
So these are all fossils that they found outside of Villa de Leyva in the desert there.
But is that a
Why?
crocodile?
Because it used to be
On the water.
ocean, right? There used to be ocean there. And then lands move and probably we had some uplift because of the plates. And now the desert is up, okay? And the water's not there anymore. So just because there's not ocean somewhere doesn't mean there wasn't always ocean there. Okay? So these are things that we need to keep in mind.
The animals were there if there wasn't ocean.
There was ocean.
Ah.
So there was ocean, the animal died, became a fossil, and at some point, because of plate movement, right, probably some uplift happened, then the land went above the water, right, and became desert. And then the wind whipped through the desert, eroding it, and then now we see the fossils.
Where did the ocean go?
To the other side? You missed the whole other video, so.
Rick!
Alright, so, level 1, only 2, wait. Yeah, real quick, create a claim with evidence about past plate movement. So what do we know about, or think we know about past plate movement? With evidence, create a claim with evidence about how marine fossils can wind up on the top of a mountain. And then level 3 is the two models. One about the spreading in the new seafloor, and the other about that then later now model of a marine animal on top of Mount Everest. Let's go.
Where?
You know?
Yeah, going to go frames.
No.
What are plates?
Plates are huge sections of earth that are moving.
Can I do with a virtual?
You got it. We have 2 new pieces of evidence just from today. Even one, the idea of seafloor. But the idea of
But
seafloor is
what are plates?
plates are giant pieces of land that are moving.
So all of South America is on top of a plate. All of the Atlantic Ocean is on top of the plate. The whole thing is moving. Past plate, what is your claim about the plates? Has it always been in the same spot? They used to be together? And what's your evidence to support that? It's just right now. Level 2 is right now. All this is from today. Level 1, have the plates always been in the same spot, or do you think they have moved, and why you think that? Level 2, we just went over how does a marine animal get to the top of a mountain. What's your claim about that? What's your evidence? And level 3 is 2 models. All of this we did today. I know it's a lot, but we did it.
How about we start the plate?
Claim is I believe the plates,
Or I think.
I believe.
a reasonable idea about plate movement is.
I believe in plate. I believe.
The ridge.
That thing that is underwater, like
The magma.
I believe.
I mean, I would suggest doing work, man. I mean, that's how you're going to know what you're supposed to know and, like, do. Because then we try it, and it goes well or not, and we learn from it.
Usually I know so much to me.
Huh?
I know so maybe.
No, I'm fine. It's going to be hard. It's
No way, pero porque, o sea, como, I believe the plates were changed of day and color of the world. Okay.
So Sophia, just so you know, we believe there was they were all together, called Pangea. So we believe that this is what we believe based on evidence. Does it mean it's true? No. But because the fossils are similar, because rock strata is similar, because of sea floor, because of the shape, we can say, we think, right, we have a claim based on evidence that everything used to be together. Could this be 100%? No, it could be totally wrong. Okay, but based on what we see, this is what we think.
And what was it? Why was it called Pangea?
That's a great
Because of the
question. Someone did.
Because it looks like it was following a record in a lot of years.
Okay, we can be more specific. We talk about like plates, the age of plates. We talk about fossils. So
Labels are great. I bet, I believe you. Yeah, I believe it.
So like the immortals here. The virgin
Right in the seafloor?
I can say like the surface color. I guess so.
Sure. know that they're spreading? There was a specific piece of information that we shared today. We looked at it in a table and a map.
Did I do that? Hold on a second. Hold on.
Mr. Light, I don't understand level 3.
It's the making the two models, one of the new seafloor, the spreading, and one of the marine fossil getting on top of a mountain. Don't understand what? Huh? The other thing? Good.
Level 3. I mean, two models today. One is the spreading seafloor, and the new versus the old. And then one of a marine animal getting onto a mountain and then being
I
exposed.
do it here. Mr. Light, I do it here.
There's one where I think they're spreading, right? Like this is newer seafloor, older seafloor. That was a model that we showed. And the other one of a marine mammal, mountain, erosion.
But Mr. Light, because I do it here. I don't remember the Mr. Light. I do it here. It's okay.
Was that from before?
No.
Honestly, it wasn't like not from what I did.
Here's the
And what's up? What do we call up? About 90 seconds.
And how do I do the other one? I don't understand.
Although, like, if you combine a bunch, we would want to do it in like 3 different sections. But it's a good story.
Yes.
That's what I need to know.
I'm going to show you the one about the seafloor spread.
So do I do the other tomorrow?
I'm about to show you in 1 minute. So just try. It's okay to try and not do it. Just try and get it wrong, you get it wrong. It's just practice. So let's say you play soccer. Soccer, right? You go to soccer practice and you're just like, nah, I'm not going to practice. What do they say?
No, because it's different.
No, but do you make mistakes in practice?
Yes.
What? And they don't kick you off the team?
No.
It's the same thing, right? It's just a practice. Like, who cares? I'm not going to kick you. You don't get a bad grade on this. And if you don't practice, it's hard to learn. Can you imagine going to soccer practice just sitting there? Nah, I'm fine.
But let's see.
They're like, no, like, try the kick. Nah, I'm fine. No, I don't want to try. I might get it wrong. I'm like, well, no, just kick it. Nah, I'm going to get it wrong. I'm not going to try. That'd be weird. It's the same thing. It's the same thing.
I'm gonna wait there.
All right, so I'm going to share with you the two models in about 30 seconds.
We need to do one of the seafloor and one of
The marine fossil on a mountain. All right, here we go. Here are the answers. All right, so this is our first model. All right, we need 2 plates. They need to be spreading. Okay, we need a spreading boundary. And we have something coming up. We can call this magma. We don't have to. But we know that there's younger seafloor here and older seafloor the farther away we
They
go.
are not colliding.
Okay, they are not colliding. They are spreading. Okay, the second one, this is when you want to show it in 3 parts. Then, later, and now. So way back then, we have an ocean in between India and Asia.
And how we
Okay,
know?
and we have a fossil. Basically, because of the ocean fossil, there's no other reason we can think of that an ocean fossil would be on a mountain. So we have the ocean fossil, then it collides. We have uplift creating a mountain. That ocean fossil that was on the seafloor is now part of the mountain. And then years go by, we still have uplift, but we also have erosion. Okay, and that erosion removes the rock. And so if we have this fossil, there's a lot of rock on top, erosion removes the rock, well now I can see the fossil. Okay, so that's the process. Questions before we, oh, sorry. So again, that is then, later, now. Then, later, now. Cool. Stop.
Or 11 and 12. I should have updated it.
All right, question number 1. What is a mid-ocean ridge?
So there are going to be 10 questions.
No. It's gonna be 5.
Thank you, sir. So mid-ocean ridge is where this new seafloor is being created.
So when
The most important is the new seafloor being created. That's where what is happening in the ridge.
Where new seafloor from?
Better.
I can put the new seafloor. is
Where
created.
new seafloor is created.
No. For the last 7 minutes. What happens to the age of seafloor rocks as you move away from the ridge? So we have the ridge where everything's being created. The farther we go away, what happens to the age of the rocks? So many yawns today. So many yawns. It's almost like you guys had a 3-day weekend and didn't get enough sleep last night. They get older. The rocks get older. The farther that we get away from the ridge, the older the rocks become. Are, not become. The older the rocks become. Question 3. If older seafloor is farther from a ridge, what does that suggest about how new seafloor forms? Where is the new seafloor forming? The new seafloor is forming at the ridge.
What can we put?
That is,
At the ridge.
It's forming at the ridge.
It's forming a ridge.
When are we
At the
going to
ridge.
have summertime?
we have another assessment coming up. You missed one in which I will start to give a grade for the unit, right? After the second one, which we'll get all of our materials
So I don't
back.
have the one I need.
You don't have, yeah, you missed that one.
So I don't have to do it. Because it is formative.
I mean, it's,
there's too much
if you don't show, we'll have to see. Because there'll be this next assessment, won't have some of those ideas on it, but you will have a chance to test those ideas in a later assessment, so you don't have to take it. But it's more evident. What are 2 processes that can change a mountain's height over a long time? One that builds up and one that wears down.
Uplift the road.
Again, we have one an assessment on Thursday, and then you'll have another one after spring break, after small class.
It's all, everything's on school. I put that on there a long time ago. Uplift and erosion. Uplift and erosion. And real quick, just a few words. How can we get a marine fossil on a mountain?
They collide.